Hello everyone, welcome to Engineering and Economy. Today we are going to discuss about how module mismatch affect the solar PV system output. Most of you already knows that solar PV modules have different current rating and voltage rating. We always talk about power output. Let's say the solar module have 250 watts module, 350 watts module, 400 watts module. Likewise, we are talking about only the what is the watt output. But there is another rating, that is a current rating and voltage rating. So usually in solar installers, they always use the same size of panels, same size of module in technical words to installation. But sometime if they mix different size of module, it create problem. So we are going to discuss about what kind of problem it will create if you mix with different size of module. Okay, this may be one of the reason for mixing two different kind of module is like you are adding another install. Let's say you install 5 kilowatt system. Later after 2-3 years you are going to add another 2 kilowatt panels. So the original panels may be bought from some other company, and another panels after 2 years you buy from another company. So these kind of many different situations, when you expand the project, you may mix up with the panel size. So we'll come back to the fundamental. What is the fundamental here? To understand this, you need to watch this series and parallel combination of solar PV module. Please go and watch in this in our channel. So what is the understanding here? I mean, if the panels are in series, the current rating should be same. Okay, if the current ratings are different, then what is the output current rating? It will be the lowest current rating will come as output. What is this means? Like let's say I have two module, one is 5 ampere rated, another one is 7 ampere rated. If I connect these two module in series, what is my output? My output will be the lowest current rating, that is a 5 ampere. Okay, similarly in the parallel connections, the voltage rating should be same. You know that, see, parallel connection is the voltage should be same. If the voltage are different, then the lowest voltage rating will be my output. Okay, so that this is the mismatch created if we mixed two different type of two different specifications of module. So let's look at here. This picture very clearly explain the situation here. Okay, here by looking here, you can simply understand this is a parallel connection. So parallel connection of three panels. We usually say panels in a simple words: panel 1, panel 2, panel 3. So what is the problem here? Here is the problem is that we have three different size of panels. So one is 8 volt ratings, 8 voltage, another one 12 voltage, another one 18 voltage. Even though this is a high rating 18 voltage, it cannot, the output cannot take the 18 voltage. Output will take the lowest voltage because it's a parallel connection. So you know the parallel connection in very basic, in fundamental, parallel connection is like this. Okay, this is your parallel connection. So the voltage should be same between every load or everything. Okay, this is a parallel, simple parallel connection understanding. Okay, so what is here? Even though we have a high voltage rated 18 voltage panel, that is a panel 3, but we are getting output as 8 voltage. Okay, this is the problem here. What is the problem here? I have a 18 voltage panel, but because of the panel mismatch, my output will be 8 voltage, not 18 voltage. It's clear? But the current, let's look at the current. Current is, this is 5 ampere, this is 5 ampere, this is 5 ampere. So current will be added, 5 plus 5 plus 5 become 15 ampere. That's fine. For the parallel connection, current will be added. So current can be any number, not a problem. Okay. But in parallel connection, the voltage should be same. So if it is not same, that is a voltage mismatch. This voltage mismatch is created because of the wrong design. Okay, this is not created because of any external factor like a weather or anything. This is basically wrong engineering design. Okay, so now you understand the voltage mismatch. You can see another example of voltage mismatch. Here we have different panels connected in parallel. So we have a 17 voltage and 18 voltage, 19 voltage and 19 voltage. But because it's having different voltage rating, the lowest voltage, that is 18 voltage, will be considered as an output. That is the mismatch created. So when a 17 voltage as output, your total output will be 476 watts. This is lower than the actual rating. If you add this 85 plus 126, 152 and 153, if you add, you will get like 85 plus 126 plus 152 plus 152, I think you will get around 515 watt. So your panel output should be this one, but you are getting this much because of a design mismatch. You're losing some amount of watts. Okay, this is a voltage mismatch. Let's go to the current mismatch. Current mismatch comes when in the series connection you have a different current rating. Look at here, this is a series connection. In series connection you can have a different voltage rating. That's fine because voltages are going to add it in the series. But look at the current rating. This is 5 ampere, this is 7 ampere, this is 8 ampere, this is 8 ampere. So because of different current rating, this going to take the lowest current. The output will be the lowest current. This will be your output current. So what happened, because this is your output current, your total, the voltage will be added. All the voltage is 73 voltage. So total power output become 365 watts. This is much lower than the actual. This is the same 4 panel. So actually you have to get the 15 watts. This is the panel. If you add the panels, you need to get this much. But what you are getting is 365, because this is the, because of the poor design. It's because of the current mismatch. Okay, let's look at this in this another picture. I put a lot of picture because it's keep on explaining the concept. So here look at that 200 watts panel and another 200 watts, 100 watts, 100 watts. So altogether you had to get 200, another 200 and 100 and 100. You need to get, in fact, 600 watts output. This is expected output if the panels are wired in a proper way. But how much you are getting in this wire connection is 450 watts output. So minus 150 watts is loss of loss loss of 150 watts. Why this loss happened? Because the connection here is a series connection. Series connection means the current rating should be same, but we have a 5 ampere, 5 ampere, 8 ampere, 8 ampere. So lowest current rating will be considered in the output. So what is the lowest current rating is 5 ampere, and the voltage will be added. So multiply by voltage. What is 25 plus 25, 50, 50 plus 20, 70, 70 plus 20, 90. So 90. This become your 90 voltage. This is equal to 450 watts. This is how you got the 450 watts. But in fact the panel can perform up to 600 watts if it wired in a proper way. So it's a clearly a current mismatch. Okay, look at here again. Another mismatch is a parallel connection. So again the voltage mismatch, because here it's a parallel connection, so voltage should be same. But what we have, 25 voltage here, 25 voltage here, 20 voltage here, and 20. So 20, because 20 is the lowest voltage, so in this connection it will take the lowest voltage. So because it take the lowest voltage, your total output reduced. Okay, so many people do not know. That's why I just want to introduce this topic. That's rarely happens because usually designers perform very well designed, but mistakenly, like if you already have a solar PV system, you are adding some more, let's say 1 kilowatt panel, then the new panel may be having different ratings and bought by from another company. This mixed up and create the losses. Okay, this completely we can avoid it because it's depend on the designers. It's a consultant like me, so it's fully depend on how you design the system. So thank you very much. Please subscribe this channel so that you can get similar videos in the future. Thank you.